Hello Year 10. Today we are looking at parallel lines and perpendicular lines, but we're quickly going to review distance and midpoint from last lesson first. So to find the exact distance between -2, 7, we're going to label these x1, y1 and x2, y2. Then the distance is found using the distance formula, which is d equals big square root of x2 take x1 squared plus y2 take y1 squared. Subbing into the formula, we have big square root, x2 is 3, minus 2, so plus 2 squared, plus y2 is -1, minus, so, sorry, not minus, just minus 7, close bracket squared. Then to find the exact distance, when you put this in your calculator, ignore the square root sign and just type in the brackets underneath. So 3 plus 2 bracket squared plus -1 minus 7 close bracket squared, and we get 89. So the answer is square root of 89. Second question, we're finding the midpoint, which has a formula x1 plus x2 over 2, comma, y1 plus y2 over 2. Subbing in, we have x1, y1, x2, y2. Putting in the formula, x1 is -2 plus 3 all over 2, comma, now averaging the y values, -6 plus -2 over 2, close bracket. And calculating the first fraction, -2 plus 3 is 1 over 2, so that's a half. And then comma, 6 minus 2 is -8 over 2 is -4. So the midpoint is a half, -4. Okay, moving on to our parallel and perpendicular lines. To know whether lines are parallel or perpendicular, we need to know their gradients. So if we're comparing two lines, we would call M1 the gradient of the first line and M2 the gradient of the second line. If the gradients are the same, if we find out that the M1 is equal to the M2, that means that the lines are parallel. If we can multiply the M1 with the M2, and that gives us a -1, that means that the gradients are perpendicular, which means they are at right angles or 90 degrees to each other. Okay, so that's those formulas there that I have highlighted. Sometimes you might be asked to find a gradient that is perpendicular to something, and that's this next formula here. But that's useful, is if you find the negative reciprocal of the first gradient, that would be the gradient of the perpendicular line. Okay, so question 1. Are y equals 3x plus 1 and y equals -1/3 x minus 5 parallel, perpendicular, or neither? So they're neither if they don't work with either of those formulas. So first of all, let's write down what the gradients are. From the first line, y equals 3x plus 1, the gradient is the 3 that's sitting there in front of the x. So m1 is equal to 3. Looking at the second line, again, the gradient is what's in front of the x, so m2 is equal to -1/3. Okay, so there's my two gradients. They're obviously not equal to each other, so they're not parallel. So now I would check to see whether they are perpendicular. m1 times m2 would be 3 times -1/3, which does equal -1. So that because that equals -1, that means they are perpendicular. If the gradients are not the same and they do not times to give, oh, I've put perpendicular. If the gradients are not the same and they do not times to give a -1, that would mean that they are neither. Let's try another question. Are y equals half x and plus 6 and x minus 2y plus 4 equals 4 parallel, perpendicular, or neither? Okay, the first equation is in y equals form. So we can read off that the first gradient is equal to a half. The second equation, though, is in the wrong form. I need to get the y by itself before I can read off the gradient. So I don't like the 2y there being negative. So I'm going to move the 2y across to the other side. It'll be x equals 4 plus 2y. Then I'm going to subtract the 4. So 2y equals x minus 4. And then to get rid of the 2, we divide everything by 2, which would be half x, and minus 4 divided by 2 is minus 2. Okay, so now that we're in y equals form, the gradient, the second gradient, m2, is equal to that half. m1 is a half, m2 is a half. Because they are equal, that means that they are parallel. Question 3. Are those lines parallel, perpendicular, or neither? So we have a third one of these. The first one is in the right form, so m1 is equal to a quarter. The second one is not in the right form, but the y is positive here, so let's leave it where it is and move the minus 4x across to be a positive 4x plus 1. That would mean that m2 is equal to 4. m1 is equal to a quarter, m2 is equal to 4. They're not equal, so do they times together to give -1? So we have a quarter times 4, they equal a positive 1, not a -1, which means they're not perpendicular either, which means that they are neither. Question 4. Find the equation of a line which is parallel to y equals 2x plus 5. What that first line there gives me is the gradient, and it's telling me that the gradient is 2. Because that's parallel, that's the gradient that I want. It has to be equal to that gradient. M is equal to 2. And it passes through the point 1, 3, so I have a point and a gradient, which means that I can use my point gradient formula. So this will be x1, y1 that I'll substitute in. Y take away 3 equals 2, bracket x take away 1. Expand it out, and then move the 3 across to the other side. So minus 2 plus 3 is a 1. Okay, question 5, find the equation of a line which is perpendicular to y equals 2 over 3x minus 1. Perpendicular is different to parallel. I know that the first gradient is 2 over 3. That would be the parallel gradient. But I want the perpendicular gradient, which we call m2. Now, the formula is -1 over m1. So you can sub that in and you go, oh, that's -1 over 2/3 and blah, 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 blah. That makes a -3 over 2. Some people don't like to remember the formula, so it's often easy just to go, it's the negative reciprocal. So if it's a positive, it's going to become a negative. If it's a negative, it's going to become a positive, and the fraction will turn upside down, is what reciprocal means. So that's how you get a -3 over 2. Then I want to use that gradient and the point 2 minus 5, so that will be my x1, y1, and sub it in yet again to my point gradient formula. So y minus minus 5, so plus 5 equals -3 over 2, x minus 2. Expanding out, y plus 5 equals -3 over 2x. That would make a plus 3 when you times the -3 over 2 with a -2. Then, subtracting the 5, we have -3 over 2x. 3 minus 5 makes -2. Question 6 is my little challenge question for the day. Find the value of a if y equals 2a plus 1 over 3, all in brackets x. So that bracket is the gradient that's in front of the x, plus c is parallel to y equals minus x minus 3. So looking at the first equation, like I said, that 2a plus 1 over 3 is the gradient, so that's the m1. The m2 comes from the second equation here, which is a nice normal one, which is -1. They're parallel, which means those two gradients need to be equal. So if I just make this into an equation, 2a plus 1 over 3 is equal to -1, I can solve it to find out what a is. So timesing the 3 over, I get -3. Then subtract the 1, I get -4. Divide the 2, and I get -2. So it's not too tricky to solve, it's just about understanding the question from the beginning. It just doesn't look familiar. All right, let's now go to exercise 1H, please.